400 kilometers above Earth, there is no air, no ambient heat, and no margin for error. It is a completely silent, hostile vacuum. Yet drifting through this dark expanse is Tiangong, or the Heavenly Palace. Weighing 77 tons, this is a third-generation modular space station permanently hosting a human crew. This outpost is the direct result of a specific three-step strategy initiated by China in 1992. Step 1 focused on basic crewed flight. Step 2 launched the Tiangong 1 and 2 prototype labs to test orbital living. Step 3 is the permanent station itself. Assembling a structure this large in space requires lifting massive, delicate components through Earth's atmosphere and aligning them at thousands of miles per hour, all while managing strict fuel limits and zero-gravity physics. By solving these physical and logistical constraints, this once hostile void has been engineered into a permanent, self-reliant human foothold in orbit. In 2021, the station did not exist in space. Over the course of just 11 months, a rapid sequence of heavy-lift rocket launches brought the massive cylindrical sections into the darkness of low Earth orbit, where they autonomously maneuvered and interlocked. The final layout is a distinct T-shape. The central hub is the Tianhe core module, which acts as the primary control center. It is flanked by two specialized laboratory modules, Wentian and Mengtian. Holding these massive sections together is the Chinese docking mechanism. When the modules meet, their circular transfer passages lock to create an airtight, pressurized seal, capable of withstanding the extreme thermal shifts of orbit. The efficiency of this docking system was tested in 2022, when the Tianzhou 5 cargo ship launched from Earth and securely mated with the station in exactly 2 hours and 7 minutes. Once assembled, the exterior architecture powers the station. Massive 2-axis steerable solar arrays track the sun to generate continuous electricity, while a 10-meter robotic arm crawls along the hull to assist with maintenance and spacewalks. Executing an 11-month assembly sequence, complete with automated rapid docking and complex exterior robotics, proves a mature capability in heavy-lift orbital logistics. If you cross the threshold from the lethal vacuum of space, you enter a highly controlled, brightly lit cabin pressurized for a crew of 3. Keeping that crew alive falls to a complex system called ECLSS, or the Environmental Control and Life Support System. This animated chart shows exactly how ECLSS handles waste. You can see the continuous fluid flow converting human urine and atmospheric moisture into clean drinking water. A portion of that water is then split through electrolysis, using electricity to separate the hydrogen from the oxygen, creating a steady supply of breathable air. With basic survival secured, daily operations take on a structured routine. The 3 taikonauts sleep in individual, noise-regulated quarters, and their diet is selected from a curated menu of 120 different meals. Navigating the interior feels like a smart home. The equipment and modules communicate over a completely wireless Wi-Fi network, and the crew uses handheld tablets to control the ambient cabin lighting. That lighting is actually a critical medical tool. Because the station orbits the Earth so quickly, the crew experiences 16 sunrises and sunsets every 24 hours. The interior LEDs artificially simulate a standard Earth dawn and dusk to meticulously maintain their natural circadian rhythms. The crew's primary task is managing 25 specialized experiment cabinets devoted to microgravity physics, biology, and material science. Every data point generated here is continuously monitored by teams at the Beijing Aerospace Flight Control Center. By combining regenerative air and water with wireless device networking, the interior operates as a highly optimized, fully connected laboratory for continuous human habitation. The station is designed to share its orbital neighborhood. Around 2027, China plans to launch the Xuntian Space Telescope. Xuntian shares Tiangong's exact orbit, close enough for access but safe from vibrations. Compared to the Hubble telescope, Xuntian matches its resolution, but its optical sweep is 300 times larger, surveying vast sections of the cosmos at once. Because they share the same orbital path, Xuntian can autonomously navigate to the station and dock. This allows the crew to refuel the telescope, perform hands-on maintenance, and upgrade its hardware without requiring a separate launch from Earth. Testing autonomous docking, robotic arm manipulation, and highly closed life support loops serves a purpose beyond low Earth orbit. These are the specific systems required to sustain human life further out in the solar system. By operating Tiangong today, engineers are actively stress testing the technological foundation for China's planned crewed lunar missions in 2030. Through its open scientific platforms and continuous technological refinement, the station secures a permanent human presence in the stars, serving as the definitive bridge between low Earth orbit and deep space.